Okay, so welcome to the tutorial about change of basis. So let me write number 6, 5, sorry, number 5, example, and here is the question for the tutorial. Okay, so it says consider the basis B and D, okay, from R2 such that B equals minus 1, 1, 2, 2, and D equals 0, 4, 1, 3. Okay, so part 1, we are asked to represent V, which is equal to minus 3, 4 with respect to B and D. Respect to B and D. Number 2, we are asked to find the change of basis matrix for BD. Okay, find the change of basis matrix for B and D. Solution. Okay, so you want to represent, so you want to find the representation of V with respect to B. Okay, and you know how to do that. We take linear combination of the vectors of B. So we have C1, the element of B are minus 1, 1 plus C2, 2, 2 equals to our vector V, which is minus 3, 4. So we have minus C1 plus 2C2 equals minus 3, and C1 plus 2C2 equals to 4. Okay, we can perform Gauss. Okay, so we have a rho 1 plus rho 2 plus rho 2. That's why we have done Gauss method, is to be able to solve linear systems of equations. So we have, let's make use of it here. 2C2 equals to minus 3, and 4C2 equals 1. So that means C1, C2 first of all equals to a quarter, and C1 equals 3 plus 2C2, which is 3, plus 2 over 4, okay, which is 3 plus a half, which is a 7 over 2. Okay, so that's C2, C1. That means the representation of V with respect to B is C1, C2. So it's 7 over 2 and 1 over 4. Okay. So now let's find the representation of a representation with respect to D of the vector V. So we are going to take linear combination of the elements in the basis D. So we have C1 0 4 plus C2 1 3 equals minus 3 4. So we have C2 equals minus 3, 4C1 plus 3C2 equals 4. So we don't need to do Gauss method here. We are lucky. So we are given C2, C1 equals, let's start with 4C1 equals 4 minus 3 times C2, which is equal to 4 minus plus 9, which is 13. So that means C1 equals to 13 over 4. Okay, so we have C1, we have C2. That means the representation of V with respect to D is 13 over 4 and minus 3. Okay. So question 2. Question 2. We are asked to find the representation, the change of basis matrix. Asked to find the change of basis matrix for BD. Okay, so we have seen in the lecture that the change of the basis matrix for BD is the representation of the identity map with respect to BD. Okay, so I'm here. This is the formula. So we have seen that the representation, the change of basis metric is the representation of the identity map with respect to BD, which is equal to the representation with respect to D of the element of the basis vector B. Okay, so what we have to do is here we have the element of the basis vector B. So B, recall, is the element of B. 1 minus 1, 1 minus 1, and 3, 2, and the element of D. I hope I'm not mistaken here. Is 1 minus is the other way around. Okay, is minus 1 1 and 2 2, and when it comes to D is 0 4 1 3. Okay, yeah. So here is a beta 1, here is beta 2. Okay, so what we are asked here, what we need to do is to find the representation of D of beta 1 with respect to D. So here I need the representation with respect to D of beta 1, and beta 1 is minus 1 1. Okay, it's going to be equal to linear combination of the element of B of D. This time is that the element of D, not B. So we have 0 4 plus C2 1 3 equals minus 1 1. Okay, so we have C2 equals minus 1, 4 times C1 plus 3 times C2 equals 1. So have here C, that means 4 times C1 equals to 1 minus 3 times C2 equals 1 minus plus 3. Okay, so that means C1 equals to 1. 4 times 4 divided by 4. Okay, this one. So here C1, C2. So this is 1 minus 1. And here, let me go here so that I can have no space. Maybe let me stay here. The representation with respect to basis D of the second element of B is 2, 2. Okay, so we have C1, 0, 4 plus C2, 1, 3 equals 2, 2. So we have C2 equals to 2, and 4 times C1 plus 3 times C2 equals to 2. That means C1 4 times C1 equals 2 minus 3 times C2, which is 2 minus 6, which is minus 4. So C1 equals to minus 1. Okay, so we have here C1 is there and C2 is there. So the representation of the second element of the B basis is minus 1 and 2. That means minus 1 and 2. Just make sure minus 1 and 2. Okay, so that means the representation, the matrix, the change of basis matrix, so representation with respect to BG of the identity map is equal to this vector concatenated with that one. So we have 1 minus 1 and minus 1, 2. So basically it says that if we are right, okay, let me change color. It says that if we are actually right, then the representation of the vector V with respect to D, the new basis, is going to be equal to the change of basis matrix representation with respect to B, D of the identity map multiplied by the representation with respect to B of V. Let's have a look if that is true. We already know how the representation, we have seen the representation of V with respect to B, sorry. So here we have the change of basis matrix here, which we have just found short a while ago. 1 minus 1 minus 1, 2. And the representation of V with respect to B, we have already found it here, is 7 over 2, 1 over 4. So 7 over 2, 1 over 4. Let's see if that is, let's multiply it out. So we have here 7 over 4, sorry, 7 over 2 and minus 1 over 4 at the top, and at the bottom we have minus 7 over 2 plus 2 over 4. So allow me to write it that way. Okay, so at the top here we have 14 over 4 minus 1 over 4, which is 13 over 4 at the top here. So we have 13 over 4, and at the bottom here we have minus 7 over 2 plus 1 over 2, which is minus 6 over 2, which is minus 3. Minus 3. Let's have a look. We have already already found the representation of V with respect to D. So let's see if that was the case. What did we get for the representation of V with respect to D? That's what we found. Okay. 13 over 4 minus 3. Bingo. 13 over 4 minus 3. Okay. So this is check. We are just checking it here. If what we have done is actually true, of course, it should be true. That's the theorem and the definition, so it must be true. So basically, I'm going to stop here. So in this tutorial, we have seen how to find the change of basis matrix. Is that okay? Thank you, and I will see you in the next video. We will continue with the lecture. In next video, we will see the change of map representation. Okay, so talk to you soon. Bye.